the direction of angles of 3D vectors. And so we're looking at the angles in relationship to the x-axis, the y-axis, and now the z-axis, adding in that dimension of depth. So we're going to get some variables that are a part of the Greek language. We're going to get alpha, beta, and gamma, and those are going to be our directional angles and how they relate to the positive x-axis, positive y, and positive z-axis. So it's going to kind of give us directions to how we would get to the vector. So what we're doing today is we are finding what are called direction angles. So again, the direction angles are if this darkened line is my vector, again, it's how did I get there from the positive x, y, and z axis. This is another spot where you're going to say, ooh, I hope we have a formula sheet on the test. And if you don't remember me talking about it before, the answer is yes, you do. Okay, because there's a lot going on. If it was just like one of these formulas, they're not that bad. Okay, they're not a super tricky formula. But because we have so many different little formulas, that's the reason why I feel like we need a little bit more here. Okay. So we need to find the directional vector, but we need to find it for the horizontal component, for the vertical component, and for the component that gives us our depth for z. Do you see how they're the same formula for all three? So that's the good news. But we need to keep them separate in our mind as working with the horizontal, working with the vertical, working with the depth. So we need to do each one individually. Okay, so alpha is going to be my variable that goes along with the horizontal, beta for the vertical, gamma for the depth. Here we go. So we want to find the direction vector. So we're going to start a problem already. We want to find a direction vector for 4i plus 2j plus 2k to the nearest degree. And we want to find all the direction angles. Okay, so let's start up. We need to find cosine of alpha. So I'm starting with the horizontal piece. Cosine of alpha equals a1. What's my a1 value from this equation? 4. Over, what's in the denominator? What does this mean? Means absolute value. I think maybe you don't know because I don't have the notation. Remember, this is supposed to be in here too. Now what does it look like? Magnitude. Okay, so I'm going to calculate the magnitude of vector A because I'm going to need it in all three parts. So I'm going to use it 3 different times, so this is going to be useful for me to calculate. How do I find the magnitude of this vector? Yeah, square each part, add them all up. Remember that it's important if you're using your calculator a bunch, if any of those numbers are negative, that you've got to put parentheses around them when you go to square them. So I've got 16 plus 4 plus 4, which is the square root of 24. Now, if this were a final answer to a problem, should I reduce it more? Yeah. But do you see how I'm going to plug it in and use it to find something else? So it's not even going to help me to reduce it. So this is not a time you need to reduce unless that's a skill you'd like to practice, and then by all means do it. But again, I think about the test you have coming up, right? SAT and saving time. So for me, when I took that test, it wasn't so much of like not being able to do the problems, it was getting all the problems done. The timing was hard for me. And so this would be like a thing you could do where you could skip over the step of simplifying. Could I simplify and make it all perfect? Sure. But again, it's a time saver not to. And think about those types of things when you're taking the SAT next week as well. All right, if I want to solve for alpha, what do I need to do to each side? Inverse cosine, yeah? That'll undo the cosine. So this will undo this, and I will know what my angle alpha is. So on my calculator, first of all, double check that you're in degree mode. I think we checked yesterday, but if you have changed it. Maybe you need to fix that. We want to be in degree mode or we're not going to get matching answers. So inverse cosine, second cosine of 4, that's not a 4, divided by the square root of 24. All right. And it says it wants me to round it to the nearest degree. So I'm going to round this to what? 35 degrees. Boom, done, final answer. That means my vector is 35 degrees from the positive part of the x-axis, which in and of itself doesn't help me a lot, but then when I find the other two angles, then it can get me to the direct spot where it is. So let's keep going. Cosine beta, boop, boop, equals, what goes in my numerator for this one when I'm looking for beta? 2, because of this 2. Over, what's the denominator? Square root of 24. Let's just set up the other one. Cosine gamma, what goes in the numerator? 2, because of this 2, the 2 in front of the k. Over square root of 24. Practice typing those in. Tell me, well, I'll tell you what I get, and then you hopefully are going to tell me, yes, I match you, Miss Bussell. So go ahead and type them in. Just practice. Make sure that, you know, the first time you're not typing them in is on a quiz or a test day. So practice typing those in. And when you're ready, look up at the board. Spoiler alert, I'm putting up answers. So when you're ready, look up at the board and you will see what these should be. How'd we do? Good? Okay, so these aren't too shabby. But again, do you see how with all these formulas, like, look at that formula over there, the angle in between two vectors. Do you see how there are some similarities between that and this one? Like, that's the other reason why I feel like I want you to have the formula sheet. It's not how hard the formulas are, it's how similar they are too, and I think that would trip me up. And I don't want that to be the reason that you would struggle. Okay, go to the back page. We got one more example and we're done. All right, now, one other formula. So again, I kind of like to highlight the stuff that's kind of a big deal because then it catches my eye when I go back, and I can go back and look and find the formulas that I need kind of quickly. If you take the cosine squared theta of your alpha, cosine squared theta of your beta, plus the cosine squared of your gamma, you're going to get 1 every single time. So that means if instead of getting the vector to begin with, instead of getting that, if somebody gave me alpha and gamma, or beta and gamma, I could work backwards and find the other angle. So this is kind of a situation where you're being given different information. So this would be the equation that you would need given that different information. So I'm going to tell you alpha is 60 degrees. I'm going to tell you that gamma is 120 degrees. And I'm going to say, please help me find beta and also know that it's acute. And I'll explain why it matters that it's acute in a second. That's going to actually be a fact that helps us a lot. So we're going to use this formula because we don't have the same information we had in the first example. So now we need this one. All right, so I'm going to plug stuff in. Cosine squared of alpha. What was alpha? Plus cosine squared beta. Do I know beta? No, that's the one I'm after. Plus cosine squared gamma. What's gamma? 120. Now, this is a buddy of the alpha moment. Do you know 60 and 120? Yep. Okay. Cosine at 60 degrees. Cosine at 60 degrees is what? 1/2. So I'm going to plug in 1/2, and then it also is still telling me I need to square that value. I can't do anything to the next one. It's just a beta. Next, this one also needs to be squared. Now we're going to 120 degrees. What is my cosine at 120? Negative 1/2. Okay. So thinking about squaring fractions seems like it's stressful, but it's really not that bad, right? We're just squaring the numerator and the denominator. So there I am. This one stays cosine squared beta. This one is also going to be 1/4, right? Because a negative 1/2 times another negative 1/2 is going to give you a positive 1/4. All right, what do I need to do now to try to solve for beta? Yeah, let's subtract both of them over. So I'm going to end up with the thought that cosine squared beta equals what? 1/2, or 0.5. Let's go with 1/2. You'll see why it's going to be better to leave the fraction in a minute. Now, we need to get rid of the squared before we get rid of the cosine. Okay, so how can we undo the square that's there? Square root. Okay, when I square root, what symbol pops up out front? I'm going to move this over. Plus minus. Okay, and that's where the piece of information about it being acute is going to come back into play, because it's going to help me decide, do I want the plus or do I want the minus? Okay? All right, so cosine of beta equals plus minus, the square root of 1 is 1, yeah? And can I root 2? No. How can I, now this is a situation where I'm going to simplify. How can I get the root out of the denominator? Yeah, so I'm going to multiply root 2 top and bottom. So I have cosine beta equals, I'm not going to write the plus minus. Okay, so think about the plus minus for a minute. If I put in negative root 2 over 2, that would take me into quadrant 2, yeah? Or quadrant 3, depending on what the sign is. So I need to use the positive one. Because it's acute, it means it's smaller than 90 degrees. Do we agree root 2 over 2 can live in quadrant 1? Negative root 2 over 2 can't. So that's how that comes in handy. Now, when I go to take the inverse cosine, I also get 2 answers. What are the 2 things that beta could be within 1 rotation of the unit circle? 45 or 315. But again, go back to the fact that it's acute. Which one is it? 45. So again, it turns out that piece of information comes in handy a couple times, because you're going to get multiple answers and it's going to help you narrow it down to the correct one for that situation. That's it. Are we good? I told you it wasn't going to be bad, but again, it helps me when I can, and like even I can focus better when I'm teaching you stuff when I'm not listening to a bunch of other voices. So I appreciate you. Let's do that again next time. All right. So you have homework time already, so hopefully you'll be able to get it all done, mostly done. Should be all done. Page 609, 37 to 39, 41 to 42.